Okay, so first problem of the day, rods and pivots. A uniform thin rod of length L and mass M is pivoted at one end. Just look like that. It is held horizontally and then released. If friction and air resistance are negligible, find A, the angular acceleration of the rod immediately after the release, and B, the magnitude of the force Fa exerted on the rod by the pivot. So that will be our first problem. So I'll just show you the solution to this problem. Okay, sige. Okay, so the first thing that we need to do in solving this problem is, of course, draw an extended free body diagram. So, isa lang object lang naman yung nag-act dito. I'll just use, okay, so what I will be doing is I'll just redraw this such that ganito yung itsura niya. So, meron akong rod dito, mukhang square lang yan. Di naman kailangan sobrang ganda. Kailangan lang kita yung mga forces. And then, what we will be having is, I have two forces here. The one force is acting on the pivot, which is Fa, and another force, which is of course the weight of the object, is acting on its center of mass. We will assume that the rod is uniform, so that ang mangyayari ay magdodrawing ako ng force dito, and magdodrawing ako ng isa pang force sa gitna. So we will assume that the center is the center of mass of the object. So ang mangyayari, so this is just, let's say this is Fa. Masyado itong makapal to. Sorry for that. Ito dapat. So this is Fa, and this is capital Mg, where capital M is the mass of the rigid body. Now, we will, so this is the contact point of the pivot. So dyan babagsak. So ito yung gagalaw once na bumagsak yan. And this X here is the location of the center of mass of the body. So ang mangyayari, syempre meron kang wall dyan. Pag bumagsak yung ano na yan, gagalaw siya with some angular acceleration. So magkaka-angular acceleration to. The question now is, what is that angular acceleration? So first, what is the angular acceleration angular acceleration of the center of mass? What is that angular acceleration? So of course, ang pwede natin gawin dito ay since angular acceleration ang hinahanap, anong pinakamadaling hanapin muna? Anong madaling hanapin? Anong madaling hanapin? Since you determine the angular acceleration, you use force methods or torque methods. Pero since angular acceleration ang hinahanap, we use torque. Use Newton's second law for rotation. Okay. Now, Newton's second law for rotation will state that, okay, ang gagawin ko, we will assume that the direction, the positive direction is the direction of alpha. Okay? Para madali. Just like what I did in Newton's laws, ang direction ng acceleration ang i-treat ko na positive. Okay, so anong mangyayari? So this is the direction of the angular acceleration kasi babagsak. So babagsak siyang ganun, di ba? So yung pababang direction, yun yung direction ng angular acceleration. Now, so Newton's second law for rotation states the summation of torques is just equal, will give rise to a moment of inertia times an angular acceleration alpha. Now, what are the torques acting on the body? Ano yung mga torques na nag-act dun sa body?
Yung Fa.
Okay, sige. Ito, this is important. Ngayon, nasaan ang axis of rotation to? The axis of rotation is at the pivot. Wala siya sa gitna, nasa pivot siya. Remember, yung center of mass babagsak. Kasi 'di ba, from the diagram, ito yung nakakabit sa wall. 'Di ba?
Ay, joke lang.
Gets? So, ayan na. Sabi ko sa'yo, nakakalito to minsan eh. Okay. So, ganito. So, if this is the pivot, ano ngayon yung torque na ina-exert ng Fa? What's the torque exerted?
F1 is 0.
The torque exerted by Fa is just 0. Bakit? Kasi pwede mong isipin yan na pera kang R, Fa, sine phi. But what is R? What is the lever arm?
There's 0.
0, di ba? So, ito, mamamatay lang. Iyan. In fact, dapat negative yan. Kasi opposite the direction. Okay, I'll discuss to you that later. But for the meantime, the torque exerted by Fa is 0. Okay? Now, what about the torque exerted by weight? Ano yan? Meron siyang torque kasi this is the pivot. Ano ngayon yung lever arm? So, this is simply, what is this distance here? Again, the lever arm is the length from the pivot to the axis of rotation. sorry, ano raw? From the pivot to the point where the force acts. Okay? So what is this length here? So this distance here.
L/2.
Again, if L is the length or the total length of the rod, then this is just L/2. So this is now equal to mg times L/2, well, into the paper, but same direction sila with alpha, so positive yan. Kahit pa, in the usual convention, negative yan. Pero since alpha is also into the paper, parehas mo po cancel, so positive yan. Yun yung importansya ng notation na ginagamit ko, na yung direction ng alpha, yung direction ng angular acceleration, ng positive direction. So, this is just...
Pero normally po ba ang into the paper is negative?
Yes, kasi XYZ. Our right-handed coordinate system, XYZ, out of the paper ang positive. But I will be using a notation or a coordinate system where the direction of alpha is the one that's positive because I can always do that. Para lang hindi nakakalito. Okay? Sige. So we have mg/L/2 times sine. What is that sine? Ano yung angle between the lever arm and the force? Ano yan? Ano yan? So, if I extend this, ano tong angle na to? I should say, mali pala. If I extend this, ano tong angle na to? Ano lang yan?
90.
90 degrees, di ba? So this is just 90 degrees and therefore this is 1. And implying that summation of torques is I alpha, which is simply mgl/2. Okay. Now, okay, hindi ko pala nasulat dito, but note, the moment of inertia of the rod about its edge is 1/3 ml². 1/3 yan. 1/3 sa edge, 1/12 sa gitna. Okay. So sobrang, yeah. So this is just, therefore, this is equation 1, this is equation 2, substituting equation 2 to 1, we see that 1/3 ml² alpha is simply mg/L/2. Tama? So the m's here will cancel, therefore it is independent of the mass of the rod, and therefore the L will cancel, may matitira kang isang L dyan, and hence alpha is simply 3g/2L. That is the angular acceleration of the center of mass when it falls down. That's the initial angular acceleration of the center of mass. Okay, nakuha? Nakuha?
Yes, sir.
Gets? Okay.
So yung sa note po ba, sir, constant yan?
What do you mean? Pardon, ano yung sa ano?
So yung sa nakalagay sa note dyan, sir, yung sa I-rod edge.
Constant yan. Constant yan. Ang assumption dito ay yung axis of rotation ay nasa gilid. Nasa gilid yung axis of rotation. And then, of course, you can use your parallel axis theorem to determine, of course, gamit sa parallel axis theorem actually. Yung nasa gitna, it's 1/12. It's not 1/3. It should be 1/12. Kasi nagbago yung axis of rotation. Okay? Sige. Constant lang yung 1/3 ml² na yan. Given yan. Hindi ko lang nasulat sa problem statement. Pero nonetheless, that is your angular acceleration. Now, letter B. What about, ang tinatanong is what is FA? What is the magnitude of the force exerted by the pivot on the rod? So what is FA? Now, we have used already our torque relations and wala tayong mapapala dyan kung gagamitin mo yan sa pagsosolve ng FA kasi namamatay lang naman yung torque due to FA. So instead of using that, we will use Newton's second law for rotation. Newton's second law. Use Newton's second law. So if we use Newton's second law, anong mangyayari? So we have summation of forces acting on Y. It's just equal to what? Okay, again, I will assume that the direction of the acceleration, ang galing ko muna to ha, is the positive direction. So in that case, I have summation of forces acting on Y is simply MA of the center of mass. Remember, again, for a system of particles, or example of that is a rigid body, your acceleration will be acceleration of the center of mass, MACM yan, which is just equal to what? Ano lang yan? Remember, you can treat this rod here, pwede mong isipin ngayon yan as a single particle. So pwede ka mag-drawing ng free body diagram dyan, such that this is the force exerted, and this is just the weight. Pwede mong isipin ganyan yan. Pero, mag-accelerate yan downward. Tama? Tama?
Yes, sir.
So in that case, ang mangyayari, you have mg minus FA is equal to MACM. Now, we know that ACM, remember, this is a rod, and uniform naman yung angular acceleration at any given point in that rod. In that case, A and alpha are related, but alpha and ACM are related. Anong relation nila? ACM is just equal to what? Ano lang yan? This is simply R alpha, di ba? Which is equal to what? This is simply the total distance from the pivot to the center of mass, which is L over 2, times alpha. So this is equation, let's say this is equation 4, and this is equation 5. So in that case, I have an L over 2 alpha. So I can substitute equation 3 to equation 5. We have M L over 2 alpha equals, which is just equal to M L over 2 times what is alpha? This is 3G over 2L equals mg minus FA. This is equation 6. Now, I can solve for FA kasi yun naman ang hinahanap. Solving for FA, we have an FA equals mg. So, ano yan? Ililipat ko to sa kabila. Tapos itong expression na to ililipat ko sa kabila. So, you have an mg minus, what is that? So, the L's will cancel here. 2 times 2 is 4, so I have a 3/4 mg. And therefore, the force exerted by the pivot on the rod is 1/4 of the weight of the rod. So this is equation 7. Nakuha? Nakuha yung question, yung
Yes,
solution.
sir.
Ganun lang. Note na hindi tayo gumamit ng non-slip condition kasi wala namang rope dyan. At the same time, automatic na yung R alpha totoo. This is always true for this rod. Pero sa rope at saka sa pulley, hindi yan laging totoo. Kasi pwedeng dumulas yung rope sa pulley. Pero dito, hindi naman dudulas yung location of center of mass dun sa rope. It won't happen. Okay, therefore, this is always true. This equation is always true. Okay, questions? May tanong? Wala?
None, sir.
Okay, sige.